Okay everyone, hello, and in this video we group 7 will gonna present it and discuss about what is sorting in data structure and algorithm. Okay, first we're gonna introduce ourselves. Uh, the first person in this group and me as moderator is my name is Tegar Samjoe Indra Laka with student ID or name 21151010032, and the second person in this group that gonna explain about the algorithm of sorting in data structure and algorithm is Putu Bagus Muhammad Fajar with name 21151010019, and the last person that gonna explain about the example code in sorting is Kadek Bayu Danu Artha with name or student ID 21151010025. In this presentation, our group 7 will gonna present and discuss about what is sorting in data structure and algorithm. The material 2 is what is insertion sort in sorting, and the last material is what is quick sort in sorting. Okay, for the first material is sorting. Sorting refers to arranging data in a particular format. Sorting algorithm specifies the way to arrange data in a particular order. Most common order are in numerical or lexicographical order. Sorting in structured data have many different methods in its algorithm, and what we're gonna talk about of their method is only two, and the example is elementary sorting algorithm and efficient sorting algorithm. In elementary sorting algorithm that we're gonna present it and talk about is insertion sort, and one of efficient sorting algorithm we're gonna talk about is quick sort. For the material 2 is insertion sort. What is insertion sort? Insertion sort is an elementary sorting algorithm that works similar to the way you sort playing card in your hands. And the array is virtually split into a sorted and unsorted part. Values from the unsorted part are picked and placed at the correct position in the sorted part. That is insertion sort. And the way of work of this algorithm is compared to elements, namely the first element with the elements that have been sorted. The comparison will continue until there are no elements left. And the way of work in this algorithm is not suitable for larger layers data sets because the complexity of this algorithm is 0 tutup buka tutup kurung, where n is the number of items, and the first is it will be lapat, and where for each illustration this insertion sort will move to the element value and then insert it repeatedly until the element value is in the right position. So if you want to more understand about the way of work of this insertion sort, you can hear explanation about the algorithm of this sort. The algorithm will be explained from my teammates Putu Bagus Muhammad Fajar. For Putu Bagus Muhammad Fajar, you can take your time.
Okay, thanks for the chance given to me. Now I will explain about the insertion sort. As you can see here, there are many flowchart in here, but I will start with this flowchart. In this flowchart, the first is we can see the value of 9, 7, 11, 2, and 5. This is an array, and this array have 5 elements of data. the way of work of insertion sort is it compare the first data in the index 0 with the second data in the index 1. So as we can see here, the first data 9 and the second data 7 will be compared, and if the second data have value less than the first data, the data will swap like that. So this is the data after the swap, and then the second data will be compared again with the third data or the data in the index number 2. So because the third data have value more than the second data, the data will be not swapped. And after that, the algorithm of insertion sort will be checking again with the fourth data compare with the third data. As you can see here, the fourth data have value 2, and it will compare with the third data and has a value 11, and the data in the index number 3 have less value less than the third data, so it will swap again. It's something like that. After that, the data in the second index or the third data will be checking again, will be compared again with the data in the index number 1 or the second data. The algorithm will checking again, and if the third data have value less than the second data, it will swap again. It's something like that. So this is the result, and the last is compare the data in the second data that have been swapped twice before with will compare with the first data, and the data in the second data is have value less than the first data, so the data will swap again, something like that. After that, we can see this is the result of the insertion sort, and then the insertion sort will checking again the data to the last data. So the data in the last element or the last data have index the index number 4 will be checked and compared with the previous data, that the fourth data, and the last data is have value less than this previous index, and it will swap again. As you can see, this is the result, and then the same algorithm will be repeat again. The value of 5 will be compared with value of 9 and swap again because 5 have value less than 9. So this is the result, and the algorithm will repeat it again until the value of 5 or the third element meet the second element, and then the second element is have value more than the third element, so it will swap again, and is the result. And the last, the algorithm will be checked again the value, and as we can see here, the value of the second element is more than the value of the first element, so the data will be not changed, and this is the last result of our array.
For the example code from this insertion sort algorithm will be explained from my teammates Putu, Kadek, Bayu, Danu, Artha. Sorry. For Bayu, Danu, Artha, please take your time.
Okay, I will be continue to explain about the program to insert sort. So in this program, I'm use the C++ language, and in my program, in the main program, I am declaration the array. The name is data, and this array will be I'm sorting with my program. And next, I'm declaration 3 variable, to help me to sorting this array. The first, before I make the sorting, I will be make the output to display the origin data in array before sorting, and after that to sorting the data, I'm use the nested loop. This is because the way insert sort works is as described before by my friend. So the first loop I'm using for, and condition in for is key equal to 1, and looping will be loop if value k is small by 5, because in my array there are 5 data, and the value key is increment. And in the for loop, first is I'm make the variable value is equal to data index key, and after that I make the for again, and the condition in for this is value a equal key min 1, and value a is bigger is equal to 0, and the variable value is be small by data index a, and value a is decrement. For example, maybe this the first loop, so the value key is 1, so the value to variable value is data index 1, and in this for the value e is equal 1 minus 1, or value e is 0, and if the value or the data index 1 is be small by data index 0, the program will be continue in this condition, or the data e plus 1 or data index 1 is equal data index 0. And after finish that, after finish in this for, the program will be continue in this case. In this case is data a plus 1 is equal to value. This is mean like the value e, maybe in this case is 0, so the data index 1 is equal to value. And after finish in this nested loop, after finish to the all data in array, so the data will be ordered from small to longer, and after that I make the output to show a result in this program or after sorting, and the result of this program will be like this. You can see before sorting is same like this, and after sorting we can see this data is ordered from smaller to the longer, and this program is success, and the explanation will be continue to explain about quicksort.
The last material is quicksort. What is quicksort? Quicksort is an efficient sorting algorithm to divide and conquer an algorithm. Quicksort will pick an element as pivot and partition the given array around the pivot. Yeah. And there are many different versions of quicksort that pick pivot in different way. The way of work quicksort is a data sorting algorithm that uses data splitting technique into a partition. So this method is also known as partition exchange sort. To start the sorting iteration, first an element is selected from the data. Then the data elements will be sorted in such a way. Way of work of this algorithm is the quicksort will be takes one of the element at random, usually from the middle, and calculate the pivot and store all the smaller elements to the left of the pivot and all the elements to the left and right of it until all elements are sorted. So for more understand about way of work quicksort, you can hear about the algorithm of this sort. The algorithm will be explained from my teammates Putu, Bagus, Muhammad, Fajar. You can take your time, Fajar.
Okay, now I will explain about the quicksort. This is the algorithm or flowchart about the quicksort. For example, we have an array in here. So the array have 8 elements or 8 data. So this array have index 0 until index 7. In quicksort, we must choose one data to be a pivot. The pivot will be compared with the other data in this array. So as we can see here, the pivot can choose the first data can be pivot, the last data can be pivot, and the pivot can have value in the middle of the data. But in our data, we have 8 elements, so we can choose the value of the 4th element or the 5th element. In this case, I choose the 5th element to be pivot in this array. So let's start the algorithm. So for the first, the data in the data in this array will be divided by 2, that called by partition, and then the data that pivot will be compared with the first data or the data in the index 0. If the value of the data number 1 or the data in the index 0 have value more than data in the pivot, the data will be positioned after the pivot here. Next, the data in pivot position will be compared again with the data 2 or the second data that have been placed in the index number 1. So as we can see here, the data number 2 have value more than the data in pivot and will be positioning or places after value of 9. As you can see here, this is not order because the data only check with the pivot. And we next again, the data in the 3rd element will be checked and compared with the pivot. And because the data in the 3rd element have value more than the pivot, the data will be placed in here. Okay, next, the pivot will check and compare the previous data before pivot. Because the data have value less than the pivot, so the data will be positioning in the first or the index of 0 of array. Okay, next. Then we can see here the data in the pivot will be checking again to the data number 6 or the data that have index number 5. Because the data in the index number 5 have value more than the pivot, the data will be positioning here. So the algorithm will be repeated again. The value of the 7 element have value more than the pivot, then the value of 10 will be placed in here. And go to the last data that compare and check with the pivot. So this is the final result of our first quick sort. And then after that, the algorithm of pivot will be divided this array to 2 array. Okay, this is the first array because the first array have not have value other than 2. So the 2 we can ignore it for a while. But in the second array we have 7 data that must be checking to get the other position. And then from the second array we must choose pivot again. So in this case, because the data have 7 value, so it's easy to choose the pivot. The pivot is the middle of the data that have value 11. Okay, the algorithm is same as before. The pivot will check and compare with the first data or in the second array. So if the data is less than the pivot, the data will be placed in here, in the first element in the second array. Okay, next. This is our array before. So the data will be checked again. The second data will be compared with the pivot, and as we can see here, the pivot have value more than the second data. So the second data will be not changed and be places in here. After that, the data will be checking again, and as we can see here, the data have value. The third data of second array have value less than the pivot, so the data will be not changed and will be positioning after 9 again. And we can see here, this is not in order. Okay, let's next again. The pivot will check the data after the pivot that have value less than the pivot, so the data will be positioning in the left of pivot, but the data will be placed in the fourth element or in the second array. Next, the data will be checked again to compare with the value of 10, and the value is less than pivot, so the data will be placed in here. And last, the data will be checked the last element, and the data in the last element have value more than the pivot. So this is our final result of the second divided of quicksort: 2, 5, 9, 7, 8, 10, 11, and 15. But as you can see here, there is problem with this sort. The data is not in order. As you can see here, the second data have value more than the value in the third data and the fourth data in second array. So this is the problem. And then the sort or the quick sort will be checked again to get in order result. So this is the flowchart. The data in the second array will choose again the pivot, because the pivot is the middle of the data. We set the pivot is the middle in the data, so the pivot will checking again from the first element of second array. As you can see here, the first data that have value 5 has value less than pivot, so the 5 will be not changed and will be the first element in the second array. And then 8 will be compared by the second data that have value 9, and the value of 9 have value more than the pivot, so the value will be placed in here after the pivot. Next, the pivot will check the next data or the third element of second array, and the value will be not changed. And the value have value less than the pivot. So the value of third element will be placed after 5 in here. As you can see here, this is the data. After that, the pivot will be check the data in here. After the pivot, the data after pivot. So because the data in here have value more than pivot, the data will be not changed and will be positioning in here. Okay, I made some mistake in here. Okay, as you can see here, after the data in the pivot check the data in the fifth element, it will check the value in the index. So the index in the value of pivot is less than the value in the index after pivot. So the data will be positioning like this. This is the result, and then the data will checking again to the sixth element of the data in the second array. As you can see here, the data will be ordered in order. Okay, I made a little mistake again. Okay, this is the result after pivot check the sixth element of the data. And the last data will be check the last element of the second array, and the data will be not changed because, and the position of the array will be not changed because the last element of data have value more than the pivot. So this is the final result of quick sort of the second array, and this is our final result. So the data have been in order that we hope. So the data in order from 2, 5, 7, 8, 9, 10, 2, 5, 7, 11, 2, 5, 2, 5, 7, 8, 9, 10, 11, and 15. Okay, this is the final result of quicksort. The quicksort have more complexity than insertion sort, but the quicksort have complexity. But I think the quicksort is more efficient other the insertion sort.
The example code about the quicksort will be explained from my teammates, Kadek, Bayu, dan Artha. Bayu, you can take your time.
Okay, now I will be explain about quicksort. In this program, I'm use the C language, C++ language too. So in my program, now I'm use the function. The first is int or integer function. This function name the partition. In this function there are 3 parameters. The first is data array, the low and high. And in this function I'm declaration for variable. The first is pivot, a, g, and value. The variable pivot is equal data index low, because in this program I'm use the less most data to sorting the data, and after that value variable E is equal to low and variable G is equal height plus 1. And after that I make the looping. In this case I use while and the condition is 1. So this looping won't not stop because the value will be stay 1. And to stop that I make this. But before I explain this, I will explain this. I make the looping again, do while, but in condition data index A is small is equal to pivot, and value A is small is equal to height. So this is to the data if the will be small by pivot. And next is do. I make the do while again. In this condition is I'm use the variable G, and in this condition is data index G is bigger by pivot. This used to data in the bigger by pivot. And to stop this looping I make this in the condition if A is bigger is equal to G. We can see E is low and G is high. And this in this row, this is to switch the value in the array. You can see the value is equal data A, and data index A is equal data index G, and data index G is equal to value. This is mean maybe for example E is equal 0 and G is equal 1. So value is equal data index 0, and data index 0 is equal data index 1, and data index 1 is equal to value or data index 0. So this like the switch the value in the array. And in the row number 510, this is same like this. And in this function I make the return value is G or the height. After that I'm making the function void. The name is quicksort, and this have 3 parameters too, is the array data, low and height. And I'm declaration the value the variable index pivot in the integer data type. And in this function I make the if condition, and the condition in if is if a low small by height. And in the if I make the index pivot is equal partition or the function partition. This is to get the value from the partition, or the return value is G to get this return value. And next I make the recursion loop. In this case I call the function quicksort in in if, and in the parameter is data array, low, and the height is index pivot -1. And next is I'm calling again the quick sort is data index for fit plus 1 height. This is to the sorting the low value by low value or the to the left from forfeit, and this to the right by forfeit data right for forfeit. And in the main program I'm declaration the array. In this array data there are data like this, and I'm declaration to the variable a in integer data type, and I make the output to the show the before the sorting the origin data in array, and after that I'm call the function quick sort. This is a data array. This is low value, that's mean the low or index 0, and this is the like maximum index -1. In this case the maximum index from this array is 5, so 5 minus 1 is equal to 4. And next I make the output from the after sorting. This is the result after sorting, and the result of this program will be ordered from the small to bigger. This is the result of this program. You can see the before sorting same in this case, and this is the after sorting. The value in array will be ordered from the small to the bigger, and this program is success.
And that's all for our presentation about sorting. If we have a bad language or we have anything else, you please forgive me, and thanks for forgive us, and thanks for watching this presentation video. Thank you.